transistors was actually a milestone in the field of electronics. So today's class we are going to discuss about the basic working principle of transistors. First we'll be discussing about the basic working principle of transistors. Then we'll be discussing the major differences between the two types of transistors, that are bipolar junction transistor and field effect transistor. I'm not going to talk about the history of transistors. Let us straight jump into the working of transistors. Okay, so there are basically two types of transistors, that are bipolar junction transistors, that is BJT, and field effect transistor, which is FET. Okay, so the basic categories are BJTs and FETs. So we are going to discuss the working of BJTs today. That is, there are two types of BJTs. That is the NPN type of transistor and the PNP type of transistor. Now, what is the difference between this BJT and FET? We'll be discussing later in this video. First, we are going to see the working of NPN transistor. So, there are basically two types of bipolar junction transistors, that are NPN and PNP. We will be seeing the working of an NPN transistor. Okay, so I'm going to draw the figure of an NPN transistor now. So, the NPN transistor consists of how many terminals? There are three terminals. There is an N-type material, there is a P-type material, and again there is an N-type material. So, it consists of obviously three types of semiconductors. That is a N, a P, and again a N-type semiconductor. So, there is a N here, and there is a P, and again an N. So, this side, so if you see the size, this is it is moderate. This is the largest one, this is the smallest one, this is the intermediate or the moderate size. So this side is called the emitter, and this emitter side is N-type semiconductor for the case of a NPN transistor, and this N-type semiconductor, which is the emitter side, is a very highly doped side. So if it is highly doped and if it is N-type semiconductor, that means it consists of plenty of free electrons. So that is the case. So this is a emitter side. Now this is a P-type semiconductor, and this side is called, or this terminal is called, the base. Now considering the base, it is smallest in size and also it is very lightly doped. So if you see the base, it consists of, since it is a P-type semiconductor, it consists of very few number of holes, since it is very lightly doped. Okay, now moving on, the third terminal is called the collector terminal. Now, if you talk regarding the size, obviously from the figure itself, it is the largest in the size, and the doping, considering the doping, it is moderately doped. I mean, it is more doped, more heavily doped than the P-type, this base, but it is lightly doped as considering or comparatively with the emitter. So again, here there are moderate number of free electrons, not too less and not too much. Okay, so this is the case. So this is the emitter side, this is the base, and this is the collector. So I'm going to write the comparison between the size and the doping. So if you consider the size first, considering the size, the collector is the largest, then emitter, and then base. Then regarding the doping, emitter is heavily doped, so emitter first, then collector, then base. So this is a case of size and doping. So when you are drawing a transistor or when you are explaining the working of a transistor, these two things you have to keep in mind always. That is, while considering the case of doping, the emitter is heavily doped. It consists of a large number of, whether it is a P-type, consists of large number of holes, or if it is an N-type, consists of large number of electrons, that is a free electrons. Now, if you consider the case of size, collector is the largest in size, then emitter, then base. Now let's see the working of this NPN type of transistor. So we have already discussed about the PN junction semiconductor diode, how the electron and hole moves and how the recombination takes place and what is depletion layer, etc. We have discussed in the earlier video. So if you are not familiar with the topic, please do watch that video. I'll share the link in the description box. Okay. So here, as there are 3 terminals, so what happens? There will be how many PN junctions? There are 2 PN junctions. That is, one is the emitter base junction, that is this one, and next one is the base and collector, or the collector base junction, that is this one. So in order to make the transistor work, what we do is we apply a forward bias to the emitter base junction, that is connecting the N side to the negative terminal of the battery and also the P side to the positive terminal of the battery. So that type of biasing is called a forward biasing. So we forward bias this emitter base junction and we reverse bias this collector base junction. That is, this junction is a reverse bias in order to make the transistor work. Now when we do this, what happens is the electrons will start moving from emitter side. That is, this emitter base junction is forward bias. So the electrons can move from the emitter side towards the collector side. So what happens is this negative terminal of the battery will repel this negative charged electrons towards the base. So this electron will move towards the base and will try to recombine with the holes. So this P side or this base side is having few number of, that is very few number of holes. Since it is very lightly doped, there is only few number of holes present there. This electrons will move from the emitter side and try to recombine with the holes present in the base region. And some of the electrons will recombine in this base region. And since there is a plenty of electrons here, the most of the electrons moving will reach the collector side, because since there is only few number of holes, only few recombination is taking place and the rest of the majority of electrons will move towards the which side? So this electrons which is coming here will move towards the collector side. Okay, so hence the electrons are traveling from which side? Emitter side towards the collector side. So this electrons are injected from which side? Emitter side. So the electrons from this side, which is being moving towards the base region. So these electrons are called injected electrons. And the electrons which reach here, or these electrons in base region, are called diffused electrons. And in the collector side, the electrons which is coming from this side, or when we consider the electrons in the collector, the electrons are called collected electrons. So we call the electrons by 3 names in the 3 terminals. In the emitter it is injected electrons, in base it is a diffused electrons, and in the collector side they are the collected electrons. That is, since it is collected in the collector side, they are called collected electrons. So obviously, when this electrons is moving towards this direction, we consider by convention that the current is flowing in the opposite direction. Okay. So before considering the case of current, let's consider the case of voltage. Okay. So as I told, there are 2 junctions, right? What are the 2 PN junctions here? The emitter base junction first. So I'm going to consider this voltage which is present in this junction as VBE. So VB is the voltage present at the emitter base junction. So we know that in order to make a PN junction diode or a general PN junction to work, or in order to make the conduction happen, it should be greater than the threshold voltage. So we have discussed these cases in the video of diode. Okay. So for a silicon, this threshold voltage is equal to 0.7 volt, and for the case of germanium, it is equal to 0.3 volt. So it is obvious that this voltage we are applying here, that is the forward bias voltage should be, if it is a silicon type semiconductor, so it should be greater than 0.7 in order to make this process to happen, that is the conduction or the movement of electrons to happen. It should be greater than 0.7 if it is a silicon transistor, or if it is a germanium transistor, this voltage applying should be greater than 0.3 volt. So here I have considered the voltage present in this PN junction B, VBE, and here the voltage V, VCB. Since it is the collector base junction, let the voltage in this junction be VCB. And I am going to consider the total voltage here, that is in between the emitter and the collector. Let the total voltage be VCE. Okay, so I have considered three voltages. There are three junctions here. There are two junctions here. That is, one is the emitter base junction and the voltage in the emitter base junction is VBE, and the voltage present at collector base junction is VCB, and also the total voltage is VCE, that is in between emitter and the collector is VCE. So I can write VCE equal to VBE plus VCB. So this is the voltage equation for a NPN transistor. That is, the total voltage in between the emitter and the collector is the sum of base emitter voltage and collector base voltage. That is VCE equal to VBE plus VCB. So we have discussed the case of voltage. Now let's see the case of current. So due to the movement of electrons from the emitter to the base, a current is created which is called the emitter current, and it is directed outwards the emitter, that is IE. So due to the movement of electrons from the emitter to the base, the current created in the emitter is the emitter current and it is denoted by IE. Now due to the movement of electrons from the base to the collector, so as I told, only few recombination is happening here and the rest of electrons are moving. So due to this movement of electrons from this base region, a current is created and it is called IB, or the base current. So this is the direction of the base current. Now due to the movement of the electrons in the collector region, the collector current is created and it is denoted by IC, or the collector current. And you know that it is the emitter which is giving or donating all these electrons. So you can write the emitter current IE equal to IB plus IC. So this is the current equation for an NPN type of transistor. That is, the emitter current is the sum of base current and the collector current. Okay, so since here also the electrons are moving, right? So the collector current is created, and due to the movement of electrons from the base region to the collector region, base current is created, and also due to the movement of electrons from the emitter region, there is a emitter current. So this emitter current is the sum of base current and this collector current. Okay, so this is the current equation for the case of a NPN transistor. Now let's see the various modes of operation of a bipolar junction transistor. So there are two junctions, emitter based junction and collector based junction. So based on the biasing of these two junctions, the modes vary. So we have discussed the case when emitter based junction is forward biased and collector based junction is reverse biased. So this case is called, or this mode is called the active mode. Now when the emitter based junction is reverse biased and the collector based junction is forward biased, so this case reverses, right? So it is called reverse active. Now when the emitter based junction is forward biased and also the collector based junction is forward biased, then the transistor is said to be in saturation mode. Or saturation simply. So in this case, the transistor will act like a short circuit. Also, when the emitter base junction is reverse biased and the collector base junction is also reverse biased, then it is called the cutoff mode. So it is called the cutoff mode, and here the transistor will act like a open circuit. So these two combination, that is the short circuit and the open circuit combination, is generally used for designing of logic gates and switches. Okay. So these are the four modes of operation of a bipolar junction transistor. Now we have discussed about the working of bipolar junction transistor, that is NPN type transistor, and also the modes of operation of bipolar junction transistor. Now let's see what is the difference between a bipolar junction transistor and a field effect transistor or a junction field effect transistor. So let's understand the differences between bipolar junction transistor and field effect transistor. Okay, so as the name implies, it is a bipolar junction transistor, and here it is field effect transistor. So the major difference is that bipolar junction transistors are, as the name indicates, it is bipolar. And here they are unipolar. So everybody knows this difference, right? But what is actually bipolar and unipolar? Bipolar means the carriers, that current carriers are both electrons and holes. That is, here for a BJT there are NPN transistor and PNP transistor. So there is a combination of N, P and N. So there are electrons as well as holes. Okay, so this is the case of a BJT. Now if you consider FET or field effect transistors, or you can call them as junction field effect transistors, there are N channel or P channel. So at a time, only either electrons or holes are carriers. So hence the name unipolar. But here at a time itself, both electrons and holes are contributing to current conduction or current. So thus the name bipolar, but whereas FETs are unipolar. So either electrons or either holes are being used for current conduction or conduction. The next major difference between BJTs and FETs are, BJTs are current controlled. That is, the output is controlled by input current. Okay. So hence they are current control devices. Whereas field effect transistors, field means voltage. So FETs are voltage control devices. So you should understand these differences very correctly. That is, you should not by heart these things, you should try to understand what is happening. So here from the name itself, you know the FETs are field effect transistor, that is, they are voltage control devices. Whereas in the case of a BJT, it is a current control device, that is, the output in a BJT depends on the input current. Whereas here, the output depends on input voltage. So these two things are the major differences between BJTs and FETs. Now what are the other differences? So in the case of a BJT, the input impedance is less. For the case of a BJT, whereas for the case of a FET, input impedance is more. Also, there are three configurations for a BJT, that is common base. I'm going to write a CB, then common emitter and common collector. Whereas for the case of a FET, the gate is always reverse bias. So for that case, it has only two configuration, common drain and common source. So you should first try to understand the case of a FET, that there are three terminals. The names are drain, source and gate. So this gate for the case of a FET is always a reverse bias. So due to this, there are two configurations possible in case of a FET, which is a common drain and the common source. So we will be doing a video on field effect transistors very soon. So we will be discussing all those details in detail in that video. Okay, so that is a case of a field effect transistor. Now, next difference is that BJTs are more noisy. So there is more noise created in BJTs as compared to FET. It is less noisy. So these are the major differences. This 1 and 2 are the basic differences between BJTs and FETs. Okay, so that's it. So we have discussed about the basic working of a transistor, that is an NPN transistor, and also we have discussed the mode of operation of bipolar junction transistors. So in later on videos, we'll be doing various configurations of BJTs, that is common base, common emitter, common collector, etc. And also we have discussed the difference between BJTs and FETs. So these topics are very much important for the basic electronic topic. Okay. So I hope you enjoyed watching the video. So please do share this video with your friends and family, and also don't forget to subscribe to the channel. Thank you.